We have a sail that's using solar power to get from the Earth to the moon, and we're going to try to calculate how many days that would take. So we're given the clue that it's going to be constant acceleration, so we would assume that we would need a force that's going to provide that acceleration. And if it's perfectly reflecting, we can think, okay, well, we're going to need the F rad from the sun that's going to give us this radiation force, which is going to be equal to IA over the speed of light here. But because it's perfectly reflecting, it's actually times 2. So let's multiply that by 2. Now we're given both of these values, so we can solve for F rad. That's just going to be equal to 2 times I, which is 1370, the area, which is 6.1 e to the 5, and we can divide that by 3 e to the 8, because that's the speed of light. Now, since we know that force is equal to ma, let's go ahead and just put the ma over here and realize that we could divide the m on both sides. So we'll just put the m down here. Now, m is supposed to be given to us 6.1 e to the third. So let's just go and put that 6.1 e to the third. And now we have the value for acceleration. So let's just plug that in the calculator and see what we get. That would be 2 times 1370, 6.1 e to the 5. Then we have 3 e to the 8 times 6.1 e to the third. And that gives us that the acceleration is equal to 137 over this number here. And sure, we could put the units there. At this point, we have this acceleration. We should just go back to kinematics. So delta x is going to be equal to v naught t plus 1/2 at squared. And we are starting from rest. So this v naught is basically 0. This delta x we know to be 3.84 e to the 8. And then we'll just set that equal to 1/2 at squared. Let's multiply the 2 on this side. And then we already know the acceleration, but let's just move it over to the other side. We're going to divide that over. And so if we were to plug that in, it would be 137 on the bottom, and then the 15 thing here on the top. And then we would have to square root that to get the t. So let's just do that in the calculator. So that would just be 15, and then we got times 2 times the 3.84 e to the 8 over 137. So we could square root that to get some number of seconds. So 91692, this kind of seconds here. But what's more important is that we're going to need to do a transformation here, which should say that 1 day is equal to 24 hours. And then we can multiply that by the 60 minutes within those hours, and then times the 60 seconds within those hours. So we have all this. And so we're just going to basically multiply this by the 1 day on top and this conversion factor on the bottom. So that way we can get the number of seconds that we have. So we'll divide that by 24 times 60 times 60. And that should give us the days. So that would be 10.61 days. Crazy.